Alright, should be another draftphysics.com video presentation, I think. Anyway, so I'll do some more of the, show you the little clips of the experiment. Filmed a little better, so I did some experiments with different cameras. So I'll show some of that. So some of this will be useless. I'll do the best stuff first, then you don't need to watch much more of it. And the rest of it, I'll just go through some of the different cameras and how they did. And so I think the winner is this General Electric. It's actually a waterproof camera, really quite nice. I got it really cheap on eBay because I don't think anybody really knew how good a camera it was. So I got it for like $10. And yeah, it really is quite nice. Kodak makes made a similar camera. Actually, in terms of the quality, this one here. But and I have a few broken ones. But yeah, it's not. They all fail some way or another. They're not very durable. And this one seems to really do what it's supposed to do. It's supposed to be shock resistant and waterproof, and it is. But anyway, so I'll show the video from that first, and then we'll go over a couple other cameras, and the next stage, or the next phase, will be to put springs on the pieces of steel in different ways, piece of rubber, different things, and we'll see what kind of difference it makes. But what is sort of established is that all the energy the momentum is conserved, and there is no extra momentum going anywhere. Okay, so I think that can be stated fairly reliably. So this should be the video, and it appears to be. So I will pause and make sure I'm in the right location and the right timing and blah blah blah, and we'll do a little bit of it and such. Alright, good enough. So we can do it an inch worth, and that's what we really need. So yeah, so it's pretty clear, not too much fuzz, all of that kind of stuff. So we'll go from the 11 to the 10 here, and it seems to be a real 60 frames rather than just saying it. It actually seems like it's 60 frames. So it's pretty good quality. So 720p at 60 frames, and other cameras say it, but they don't deliver it. So that's about 11. You could argue just about perfectly. So the bottom's a little past, the top's a little behind, and we'll go to the 10. So we'll just count the frames. 1, 2, 3, 4. It looks like it's going to be a perfect 5, and it pretty much is. And so then we'll go to impact, and then we'll start right there and a half. So it's 9.5 inches for the beginning, and so 10 would be half. And if you look at the small object, it's really not going to move. Okay, so it's at 10 and a little past a quarter, 5 tenths, 5 tenths, 4 tenths. And so just remember that as we go forward. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're a little bit short of the half mark, and you can see the small thing just hasn't gone anywhere. It's just sitting there. So clearly it didn't go that way, and it didn't go that way. It pretty much transferred all the energy, and it seems like all the energy is in the two mass objects. So you have a perfect, what you would expect from conservation of momentum. That is, the 5-ton train going 10 miles an hour has completely converted into a 10-ton train going 5 miles an hour. All the momentum has been conserved, and all the energy has been conserved, just as it should be. There is no magic here. And there wasn't more energy in the little thing because it was going faster. It's the same amount of energy. So that would be 11. So pretty close to perfect, I'd say, in terms of illustrating the point and such. So we'll do one more with this camera. Okay, I'm back. So yeah, it's fairly easy to catch it early. So we can go a ways here and get to maybe the same place. It's, the closer to impact, the better in terms of getting an accurate velocity. So let's get right to the 11, and that's pretty much right on the 11. And then we'll go to the 10. So 1, 2, 3, 4, 5. It's almost perfect. 5. So can't get a better example again. And so we'll let it hit. It's about the same place as last time. So we'll go to the half. Pretty much right on the half. And then we'll go 1, 2, 3, 4, 5, 6. You can see the little one is going backwards just a little bit. So we're at 6. Okay. 7, 8, 9, 10. All right, and we're a little short. So that little bit of energy that's still in the small object is the little bit of energy that we're just under half the velocity. So click would have been perfect. 11. So 5 going in, 11 going out. Clearly as conservation of momentum would demand. So leave us do one more. Alright, this one's going a bit faster, so I pulled it back further, so it has a higher velocity, and you can sort of see that. It's going to be more like 3 per inch rather than 5. So let's go to the 11 or close to it. So we're at 11 and a tenth. So we'll try to go to 10 and a tenth, so that's right about the middle of the 0 or so. So 1, 2, 3, 4 looks like the answer. So it's a 4 this time. And we have a little bit of movement in the two mass object, but it's so little that it really doesn't matter. So we'll click till we hit, and then that's about a little short of the halfway mark. So it's a little short of 9.5. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. We got 4 going in. So, then the 4 was a little sloppy, I have to concede. But we don't have any movement, so clearly all of the energy is being transferred. The small object isn't going backwards, and it isn't really going forward. It's pretty much stopping dead. So I think there's going to be a rule about half masses and how motion moves through steel. It is curious, just because the expectation is that the small object can't give all of its momentum to the bigger object, but clearly in this case it can. So it kind of depends on the shape of the objects, I think, and what the objects are made out of. So that is a curious fact. So let's do one more, since that one was that was right on the line of, it almost wasn't half. Almost. It's very close. But obviously the incoming velocity, as I started on the 10th, it was a little bit sloppy. So we'll do one more. Alright, this one's another high velocity one. You can see it now. Alright, so a little past the 2. 1, 2, 3, 4, a little past the 1. So we're saying probably it's going to be about 4, but let's see. A little past the 1. 1, 2, 3, 4. A lot past the 2. So it's now more like 3.5-ish. And so we'll go to the 11 and do a little past the 11. So we're going to have to go past the 10. So it's going to be something 3 point something. So 1, 2, 3. 3 is a little past the 10, so we're talking about 3.2. So pretty close. 3.3. All right. So now we're at 9.5, and so we're looking for 7 would be, we could argue 7 would be half. So 1, 2, 3, 4, 5, 6, 7. Pretty much right on the nose. So, as expected. Pretty much, I'll say that again. So anyway, I'll switch to another video and a different camera, and I suppose I should go back to this, then I can show you the camera anyway. Not that it's that interesting. but it's, you know, better than nothing. So I think the second best camera was this little GoPro knockoff. It's called a Pro Scan. And it really isn't bad. I don't know if it's 60 frames, but it didn't do badly. So we'll show that one next. Right. So yeah, so I like, you know, the color isn't as good on this little camera, but the contrast and the definition, you almost can see the three-dimensionality so much better. It really is. It might be better than the other camera when you add all that crap up. Because then the frame rate stays pretty good. So not too much fuzz. So let's play this. Alright, and so maybe we'll just go to the 1. So this looks like a real 60 frames too. Looks like anyway. So we'll call that 1. So 1 is, the tip is at 1, and the rest of it's obviously past 1. So we'll go 1, 2, 3, 4, 5, 6. It's pretty slow actually. And now we're, you know, so it's a little more than 6. The tip would be at the 2, the bottom is past the 2. So we'll call that 2, and let's just do it again to the 11. So 1, 2, 3, 4, 5, 6 again. So 6 looks like the number, so we'll go with that. Should be 6 again to hit the 10. So we'll go 1, 2, 3, 4, 5, 6. So you do see a little bit of fuzz on the movement. So yeah, so it's not quite as good as the other camera. Just there's aspects, you know, like I said, the fact that it focused so well, I guess, on the tape measure is what's making it look so much better. So the number is 6. So let's go to the half. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So pretty much, you know, close. 5.5, 6, you know, whatever. It's certainly nowhere near 2/3, and it's certainly close enough to a half to say, yeah, it's a half. So we'll do another one of those just to confirm and such. I think this is good. So should have a good opportunity to see it. Yeah, it's working okay-ish. So again, it's the tape measure isn't perfectly lined up, so it's a little tricky, you know, establishing. Like I could say that's at 1.5 now. So 1, 2, 3, 4, 5, 6, 7, 8, 9. But let's go to the 11.5 to 10.5 to get the real number. Alright, so that's pretty much the fuzz edge on 11.5. 1, 2, 3, 4, 5. It looks like a 6 pretty much. So 6, and then coming out, we'll go to the 10. So we should go a little bit past the 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11's right on, 12 right over. So clearly 6 in, 12 out. All the energy got transferred. The small one's not moving, clearly indicating all the energy was transferred. Alright, so we will move on to another camera, I guess. And I have to think which one. Yeah, which one coming third. So third place was an old reliable. Yeah, I had wanted one of these for a lot of years, and I finally got a pretty beat up one on eBay. A Samsung HD is what they called it back in the day, and it's pretty good, pretty good quality camera. And a little buggy in some of the features. The buttons are a little too sensitive, this and that, different things. Battery's a little bit, can't replace it easily. It's got some disadvantages, but pretty good video. So we'll go find that one, and that'll be next. Alright, so this one really was better. I just didn't film it very well. See, that's part of the problem thing. You can't really see the screen that well when you're trying to position the camera. The tripod mount on the camera is busted, so I couldn't use a tripod, and it's a weird shaped camera, and so unfortunately, yeah, it's not ideal. But anyway, you still can see that the image is pretty good. See, it still has some fuzz in the front, so it's really not perfect by any stretch. So we'll go to the half mark, which is actually easier to see than the inch mark. So that's the half. So it's a little past the half now. So we'll just do a quick count. 1, 2, 3. Yeah, it's pretty much a little... Well, you could just argue I start a little past, I'm a little short, so we'll figure 3.2 or something. Alright, and then we hit. And we'll go again to the half mark, which is a little easier to see. So there's the half. 1, 2, 3, 4, 5, 6, 7, 8. So 3 something, and we're at 8. So clearly mostly transferred, less than, but the key thing is the smaller object is moving a little, so you can sort of see that it's a little bit of movement, so it's still moving forward, so it wasn't a complete transfer in this case. Alright, so since that video quality is so poor, yeah, I won't do more of that one. It's close, but just, yeah, my bad on that one. Alright, this one is a Sony camera, just a regular photo camera. It's actually a 20 megapixel camera, so it's the best camera I got. With an 8x zoom, which is pretty nice. But yeah, the video does suck. It's just not as good as it could be. But it's a good photo camera, so you can sort of see that the, it's a nice image, okay? But yeah, it's not a great video, so... it has some positives in the sense that, yeah, if it was taking pictures, these are nice pictures. Unfortunately, obviously, I screwed up with the tape measure being a little lopsided, and so, I have no space to maneuver at all, so I have to step over everything to get in position to do anything. So every experiment is pretty dangerous. But anyway, as tough shit, as they say. So yeah, so we'll do slow motion here. So you can see there's a little bit of fuzz. So it's not as good a video as I was hoping from a 20 megapixel camera. I thought it would do a little better than that. Alright, so we'll try to get to 11.5, and that's about 11.5 for the dark edge, not the fuzzy edge. So 1, 2, 3. We're way past the dark edge. So it's like 2.5. And then we hit. Let's get to the halfway mark. So we'll go one more. So we're a little, right about half, 9.5. So 5 would be half. So we're looking for, it's probably going to be 6. 1, 2, 3, 4, 5, 6. Pretty much on the nose. So same basic results and such. So I don't know if we'll bother doing any more. Yeah, I guess it's nice image quality, but yeah, a little bit, just doesn't have the good enough frame rate for the velocities involved. So, and all the other cameras were something worse than that. This Sony did okay. So maybe I'll do some video with this one. It's kind of a nice one. It has 2 screens, but this one doesn't work. That's why I got it so cheap. And it's like a bloggy or something. Yeah, bloggy. But it's the better quality bloggy. They made more than one kind. They should put numbers on them, for the version it is. It just is kind of silly. They have cameras with the same name, and they're not the same camera, I mean, they call this a bloggy. And this has a nice little flippy thing, and all that, but this is nowhere near as good a quality as this one. So, they shouldn't really have the same name. Alright. Camera turned on. Even though I turned the lens back off. Anyway, so maybe I'll do some with that later. Do some of the spring stuff, because it really wasn't bad. So anyway, so at least I have a camera that works well enough. So I will do some other experiments and we'll see what happens and such. I think that's it. I thought I had there was some other idea I had. Well, I thought of different ways, different things you can put on the objects, but I'm thinking I could also create a solid object and just do the simple spring experiment just to prove that springs do conserve momentum. So I'll just have to, make a device for compressing a spring with the one mass object, and then you put the two mass object and release it and see if you can get the half the velocity for twice the mass. See if you get out what you put in. So it shouldn't matter what momentum I put in. I should always get the same momentum back out. That's a good experiment to test. So I should be able to rig something for that. Just have to think of how to do it. So I'll get to that eventually too, maybe. All right. So till the next time and such, and so forth and whatnot. Yeah, that's enough. All right, so I'll put these on YouTube just so the video quality is better and, blah, blah, blah. So whatever. So till the next time and such, so forth and whatnot. As I could say, this has been a draftphysics.com video presentation. Debatephysics.com also. But no one's willing to debate physics anyway. They'll debate lots of things, but they won't debate physics.